Interpolation Grid. How to create a grid using a shapefile.
Before explaining all these deterministic models, I would like to show you how you can create a grid using a shapefile with R. That is a very important part of the regression kriging because we are going to use that grid to interpolate all these trend surfaces, and also we can use the same grid to do the ordinary kriging. The shape of the grid will be determined according to the perimeter of the data points. In that way, we are going to have a grid that is contained inside of the data. In order to avoid any type of extrapolation, we have to know that when we are working with polynomial of first order, the extrapolation is not that bad. But when the degree of the polynomial is higher, we can make a big mistake. Then the goal is to avoid any type of extrapolation when we are using any of these deterministic models. As I said, for completing this task, we are going to use the free software R. And if you don't know how to download and how to install this software, just watch the first lesson of the first geostatistics course. You are going to find all the explanations over there, and today we are not going to repeat that information. Then go to File, and we are going to create a new project. New directory, new project. First, we are going to select the folder. The folder is going to be this folder for me, and it's going to be this one. Open, and here I'm going to add Interpolation Grid. Then create project. Now let's go to add the panel for the scripts. Just R script. And then I'm going to paste here what I did already. Now let's go to the first line. And let's go to start. Let's go to run line by line. And the first thing we want to do is to check what is the directory, if the directory is good or not. Then as you can see, when we run this script over here, we can see where is located the folder. And that's the folder I want, right? That's the one I created here. This one, grid, this folder. Then this directory that we have here at the bottom, this one, has to be the same as this one, right? But if it's not the same, we can change. Copy. Then we can paste here, because I believe it's not the same. Paste. And then we can change. But when we are setting the directory, you can see that one, the bar dash is in this direction. Then we have to change here that one, right? Then select this bar and change for the other direction. Then in that way, you can indicate where you want to save all the things we are doing. Then this one, this one, this one. And that's it, because that one, it was the example. Then let me remove this one. Delete. And that's it. And then if we don't have the directory that we want, we can specify with this script, okay? Then we can run this one. And now if you check, you are going to see that you have that directory, okay? It's this one. Then the second thing we are going to do is load the data set. I have the data set in this folder. Let me show you. Here, data set. Then what I'm going to do is copy this link. Copy. And that's the name of the file, okay? I want to know also what is the name of the file. I go here, I'm going to select all this section from here to here, that is the folder, then I'm going to paste. Then I'm going to change again the dash bars for a different direction. And also I want to make sure that the name of the data set is the one I want. Okay, it has to be WorldCam Final WGS 84 Zone 13, and the format of the file is a CSV, okay? And that's the same I have here. Then for the header I want true, and for the separation I want commas, okay? Then now I can run that section. And that's it. Now I have the data set loaded over here in this panel. Remember that if you want to know how I created this data set, you can watch the first part of the second lesson of the 4th geostatistics course. In here in this video at the YouTube channel, you can see the first part, that is data capture and preparation. And here you are going to see how I get that data set. Also, if you want to download the data set, you can go to GeoRGB community website at gscourse.online, then go to courses, get enrolled at the 4th geostatistics course, then start learning, and here you have the second lesson that is about universal kriging. Here you are going to watch also where I get that data set, and also here at the exercise files you can download the data set. Now the next thing that we are going to do is create a backup of our data set that is going to be called as A2. I put the name of 8 for the data set because it's easy to manage, right? But you can put any other name. Then we can run this script, and now we can check the data set. This data set in R is going to be a data frame. Then we can see the structure of this data set. And here we have the information. As I said, that one is a data frame with 85 observations with 4 variables. And the variables, we have the ID, the X coordinate, the Y coordinate, and the groundwater elevation. Everything is in meters. Also, we can see a table if we use this script, view A. And here we have a table with the information with the 85 data points. They are piezometers, right? And also we can see the head of the table with this script, and also the tail of the table with this script. Now we are going to see how to create a regular grid. Then we can run this one. And here for the first script, what we have is the minimum X coordinate, and we define that one like that, right? The minimum, this one is the data set, and this one is the column that we want. If we go to the table, this table is the 8, and X is for this column. And here we indicating that we want the minimum for the X column. And also the same, the minimum for the Y coordinate at the table 8 at the column Y. Then we can run. And as you can see, the values for X minimum and Y minimum is located over here. Then now what we are going to do is the maximum extension for the X coordinate, and we are going to use this script. And also the maximum extension for the Y coordinate is going to define as is showing over here. And the values again are going to be saved over here. The next point is to establish what is going to be the pixel resolution for the grid. And in order to know what is the best pixel resolution for the grid, we are going to use the QGIS, and we are going to use a script that is called distance matrix. As this course is the integration of R in QGIS, I'm going to use QGIS for different things, right? Just to use both softwares. I know we can do this one also with R, but I would like to use both softwares because the course is about of the R integrated in QGIS. Then I'm going to open this one here. And I'm going to select the data set. I'm going to take this one out. If you don't know how to load all this data set on QGIS, yes, my recommendation is to watch the previous tutorial about Universal Kriging. Then go here, matrix distance. And as you can see, it's this script over here. Double click to open. Select the shapefile. Is going to be this one, the data set. Then we want the ID with the data set, and also here the ID. And then we can run. And this script is going to give us a table here. Open attribute table. And in this attribute table, we can see the distance between each of the data points, okay? Then we can order by the distance. Here we have the minimum distance and we have the maximum distance. Then we have the distance in one direction from 34 to 35 and also in the opposite direction from 35 to 34. And as you can see, the distance is the same. Then the minimum distance that we have between two data points, as you can see, let me take the satellite imagery. The minimum distance between 2 points, as you can see in this table, is 372 meters. Okay. Then when we are going to do the pixel resolution for the grid, we don't want to have a pixel resolution that is smaller than that distance. Then as you can see, this one is the smallest one, and the first one is about 616 meters, right? Then a pixel resolution of 500 meters is going to be good in this case, and that's the one we are going to use. Then we can run this one, and again the pixel resolution is safe over here, 500 meters. With the next line, we are going to define what is going to be the number of columns and also what is going to be the number of rows. Now we are going to load the SP package, because with this package we can work with spatial data. Then run. And here we are going to set the spatial coordinates to create a spatial object, or retrieve the spatial coordinates from a spatial object, okay? We have this data frame, that is the data frame A, and what we want to say is that in this data frame, X and Y are coordinates. Then when we apply coordinates, spatial coordinates to this data frame is going to become a spatial object because it's going to have coordinates, okay? And we assign that coordinates with this script over here, saying that X plus Y is the coordinates over here, okay? Then we can run this one. As you can see, 8 now is a data frame, but when we apply this one, it's going to become a spatial object. As you can see now, formal class spatial point data frame, okay? It changed the class of this object now. Now we are going to assign the coordinate reference systems with the projected coordinates. We want projected coordinates because we want to use UTM coordinates, because with UTM coordinates we can measure the distance in meters, okay? And then we are saying that this object, that is the object A, is going to have these coordinate systems, okay? These coordinate systems is the one that we can see here at the QGIS, okay? This code 32613 is the same as we have over here. If we go here 32.6.3, but also at the project properties, we can see that we have this code over here. And also the other day when we was creating all the layers, we assigned these reference coordinate systems to all the layers, right? If we go to information, you are going to see here that we have also that code over here. Then the next step is going to be to create the grid, okay? And we are going to define our grid with this name, grid, and that's the properties the grid is going to have, okay? We define all the properties over here. We already did all the values that we want for our grid, and then we specify over here, okay? And that one is going to create a object. Let me show you. Run this part, and now it's created this object that is called grid, and this one is the class grid topology, okay? And with the next section, what we are going to do is convert this grid topology to a spatial pixel data frame object, okay? And this one is the script. Then we can run, and now we can visualize the script. To do that one, we are going to use the plot. And this one is the grid. The grid has these colors because is putting inside each pixel the value of the ID. Then we can see the class for the grid to have the information. And it says that is a spatial pixels and data frame. And also we can see the structure. And here we can see all the information related with the grid, right? And as you can see, we have here the number of observations inside this grid. And it is this number with one variable. And in this case, the variable is just the ID. As I said previously, the grid is showing the ID, okay? Is this information over here, the ID. The next thing that we want to do is to cut the regular grid with the shape of the shapefile, okay? We want to cut this grid with the shape of the shapefile. Then we are going to run this one. And okay, we have an error here because we didn't install this package. Then the first thing we have to do is install the package. Then we can go here and put here install point packages, and it's going to be this one. Copy and paste over here. But first let me save this project, save. Then here is going to be Interpolation Grid. Save. And then we can run this one now. Okay, I make a mistake over here. Now we can run. Sorry, this one is another mistake here. And run. Now we have the process to be completed. And now we can run this library. Now the next thing is to create the shapefile with the perimeter of the data. We are going to do that one with QGIS. Then we go to QGIS. Then we are going to create a new layer. Create layer, that is going to be a new shapefile layer. Then we are going to save here inside this folder, and we are going to call this one as a perimeter. Then save. This one, the geometry is going to be polygon, and we want a different coordinate reference systems. That is going to be this one, the code 32613, and OK. Also, we want to activate the toolbar for the snapping, this one. We want to activate this one, and for a points, that is going to be this one. Select it already, and then we can do the perimeter with the data points. Then go to the layer, this one, edit the layer, select this one, and we can start with the addition. As we have activated the snapping tool, when we are close to the point, it's going to be indicated with a purple color. We don't want to do a grid with a lot of angles. Then we are going to do the exterior perimeter, but we are going to avoid to make too much angles, okay? Then select the point. I'm going to create the grid, but I'm going to pass the video faster. Okay, the grid is already created. As you can see, I didn't fit that much to the perimeter, you know, because I don't want to have a lot of angles. Yeah, I want to have something quite regular. Then the ID for this one is going to be number 1. Okay, and we finish already the perimeter of the data. Okay, then we can close here the edition with this option over here, save, and that's it. Now we want to import this shapefile to R. Then we are going to use this script over here, but we want to make sure that this one is correct. Then first I would like to copy the link for the grid. For the grid for the shapefile is this link over here. Then I'm going to copy, and I'm going to paste over here. Now in this case, as you can see, we have double bar in this direction. Then we want the same, paste. Or even we can use this one, this bar in this direction. I believe that one is going to work also. Let me change this one. Let's see if it works. Also, in this case, we have to add the name of the layer, that in this case is perimeter. That's okay. And also we want to add this condition over here. Then we can save, and we can run this one. Okay, that's good. It's already imported. We have the shapefile over here because we added this name, okay, for the object. Now we can plot this shapefile to see how it looks like. And we have the shapefile over here. Now we are going to convert the shapefile as a polygon with this script. And then we can see the structure, the information related with the structure. And now what we want is to make sure that the shapefile has the same coordinate reference systems that we have at the spatial points data frame, okay? To do that one, we are going to convert this object that is a polygon in a spatial polygon. And we are going to use the shapefile. And also we are going to add the same reference coordinate systems that we assign at the grid. And also now we can plot, and it's going to be this one, okay? In order to make sure that the next script is going to work well, we need to have the grid and the shapefile with the same reference coordinate systems. But as we forgot to run the line 54, that is this line over here, we didn't add the coordinates to the spatial object A, and also now the grid doesn't have that coordinates. Then what we are going to do now is to remove everything. Also this one, and we are going to run everything again. Also, I would like to take this one out because I don't want to run this one again. Then that's it. Then I'm going to select, I can close also this one over here, and I'm going to select from here to the top and I'm going to run everything together. That's how we can load all the things again, okay? Now I have everything good, and now we are ready to run the next script. That is going to be this one. Now we want to cut the regular grid with the shape of the polygon, with the shape of the shapefile. Then we are going to use this script over here. And now we can plot the original grid, that it was the regular grid. And now I'm going to show you how it looks like the new grid. Then we cut this grid according to the shapefile. And that's what I'm going to show you now. That's the final result. And then we can see the structure for this final grid. Then at the end, what we have is this one, that is the regular grid. And here this has a total of this number of pixels. Then this one is the grid that we cut according to the shape of the shapefile. And it has this number of pixels. And as you can see, this one is a spatial pixel data frame. And we save with this name. And what we are going to do now is this grid, that is a pixel data frame, we are going to convert this one as a data frame, okay? Because sometimes we need to do that one in order to do the interpolation, right? And that's the script that we are going to see now. Then we are going to run that one. That one says convert the new grid, that is this one, in a data frame, okay? Then click here, and we add a different name for this one, and is this one, and this one now it's a data frame, okay? If we also can view the table here, and it's this table, okay? We have the ID, and we have ACE1 and ACE2, that is the X and Y coordinates, okay? And as you can see, this data frame has a lot of points of information, right? This number over here. Then the next thing is to change, as this data frame has is1, is2 for the coordinates. We don't want that one. We want to change that one, okay? And with this script, we are going to change that one. And we are saying that the names in this data frame has to be this one. The first one ID, the second one X, and the third one Y. Okay? Then we made that change, and now we can see the table, and now we have the X and Y, and that's what we want. And then we can see again the structure, and it's saying that we have a data frame with this number of observation, that is the pixels. Remember that the pixel resolution is 500 by 500 meters with 3 variables. These variables are the ID, the X coordinates, and the Y coordinates, okay? And that's it for today. We are going to use this grid to interpolate the trend surface from the different deterministic models, and also to interpolate the ordinary Kriging. And see you on the next lesson.